Hi and Assalamualaikum. My name is Norazilah binti Muhammad Lizam. Matrix number 01DKA19F2022.
Hi, my name is Nur Adibah binti Yuzaili. My matrix number is 01 DKA19F2061.
Hi, my name is Nur Kalishah binti Muhammad Fairuz, matric number 01 DKA 19F2059, and I'm from DKA 3A. Let's start with introduction first. Surveying is to determine the relative position of various features above or below the Earth's surface by using the method of distance, direction, and altitude, which is ultimately symbolized on a piece of paper known as a plan or a map. Leveling is most frequently used survey skill. It is a simple concept that measures vertical distance relative to a horizontal line of a site. Leveling requires a graduated staff for a vertical measurements and an instrument called level that will provide a horizontal line of sight. Leveling is perhaps the most basic of geometric surveying operations and form an important fundamental part of almost every geometric project.
The objective of this leveling work is to explain the basic principle of the leveling process, to set up and adjust the instrument level, the leveling data and adjust for error, to perform field observation reduction and perform inspection for leveling work, to find the elevation of given points with respect to a given datum.
Okay, for now, I will continue with the equipment. Tripod. Tripod stand is three-legged support platform for the level. The main function is to ensure a stable instrument setup for reliable measurement. The legs can be adjusted to get the vertical height that required, and it must be set up again, loosen the screw and adjust again once the instrument moves. It is also to make sure the leveling tripod placed horizontally. Okay, the next equipment is dumpy level. Dumpy level, also known as a builder's level. The function of dumpy level is to determine the relative height and distance among different locations of surveying land, and it's also to determine the relative distance among the different locations of surveying land. And it is also an optical instrument used to establish or check points in the same horizontal plane. The third equipment is staff, a level staff, also called a leveling rod, used with a leveling instrument, and the function of staff is to determine the difference in height between points or height of points above a vertical datum. Okay, the other equipment used in leveling survey is staff bubble. Staff bubble is a tool to determine whether the surface is horizontal or not. The function is to ensure that the bubble is centered in the black circle. It is to check the accuracy of a level. The reading indicates the surface which is parallel to the horizontal plane. The last equipment that used in surveying is tape. Tape used in surveying to measure horizontal, vertical, and slope distances. They may be made of a ribbon or a band of a steel, an alloy of steel, closely reinforced with a metal or synthetic materials. Tape are issued in various lengths and widths are graduated in a variety of ways.
Next, we will go through the leveling work procedure. Step 1. Tripod has been set up for leveling work. Step 2. Dumpy level is setting on the tripod. Step 3. Tripod legs is embedded into the ground by step on it to make the tripod stable. Continue to step 4, which is bubble it adjust by enter it to the circle. Step 5. Crosshair line is adjusted until it's clearly visible. And step 6. The last step is objective lens is adjusted until object that you are sighting on is clear.
This picture shows the position of points and change points for leveling work. Based on the picture, we can collect some data. Among the data we obtained were the value of backside, foresight, and intermediate side for each station. For data analysis and calculation, rise fall method and height collimation method are used in this calculation. For the rise fall method, first, we need to enter the value of backside, intermediate side, and foresight correctly. Then, we can identify the value of rise and fall. To calculate the rise and fall, we must subtract the sum available at backside, intermediate side, and foresight, such as the number above is subtracted by the number below. For example, 2.554 minus 1.786 equal to 0.768. Then, when we get a positive value, it needs to be placed in the rise column, while negative value are placed in the fall column. After that, to calculate the reduced level, in the diagram has stated the value of reduced level, which is 50 meter. We need to add it or subtract it with the collimation for point A. If the collimation for point A is on the rise, then we need to add it with the reduced level. While if it is in the fall, we need to subtract the value of reduced level with the value of fall. Arithmetic check for rise-fall method use the formula of sum of backside minus sum of foresight equal to sum of rise minus sum of fall. So, when we enter the value and subtract it, we will get the same value for both of them, which is 4.722. For height collimation, we need to find the HOC. To find the HOC, we need to add the value of reduced level and also the first point for each station. For example, 50 plus 2.554 equal to 52.554. Then, 48.965 plus 1.305 equal to 50.27. For each station, the HOC value is the same. Arithmetic check for HOC also use the formula sum of backside minus sum of foresight equal to last reduced level minus benchmark. When the value is entered, we will get the same value for both, which is 4.722.
As conclusion, in leveling work, there are also error. Among the sources of error in leveling is gross error, which is the most common error in this leveling work. It consists of wrong staff reading, wrong crosshair used to read staff, wrong booking, omission or wrong entry on booking sheet, and spirit level not center. Second one is the constant error that affected by non-vertically of staff, collimation error of instrument, and staff graduation error. This often occurs when the halt staff is not upright. This will cause an error to occur while taking the reading. And the last error in leveling work is random error. It caused by weather, strong wind, ground shimmer, movement of the change point, and human error, eyesight, peculiarities.